Okay, so let's look at increasing and decreasing intervals. So these are the three kind of, rules you should know to see if a function is increasing or decreasing. So the first one is when f prime of x is greater than 0 for all x in the open interval a through b, then f, which is the original function, is increasing on the closed interval a through b. And when f prime of x is less than 0 for all x in the open interval a through b, then f is decreasing on the closed interval a through b. And lastly, when f prime of x equals 0 for all x in a through b, then f is constant on the closed interval a through b. So what this basically means is if it's greater than, then the actual function fx is going up, like y equals x, it's going up. And when f prime of x is less than 0, then it's kind of like y equals negative x, where the function is just constantly going down in that interval. And when f prime of x equals 0, then the function is constant. So you could think of it as y equals 1 or y equals 2, where the function is just constantly a straight line. It's not going up or down at all. It's just the exact same y level, the exact time. And that means the derivative of that interval is 0. That means f prime of x equals 0, and f is constant on the interval. Okay, question 1, we have find the intervals on which f of x equals 4x cubed minus 15x squared minus 18x plus 7 is increasing or decreasing. So the first thing we need to do is find the critical points. And the critical points are where we have lines of horizontal tangency or vertical tangency. And to find that, we need to see where the x values when f prime of x equals 0. Basically, we need to find the roots of f prime of x. So first, let's find what f prime of x is. So just by using the power rule, we can just see that this becomes 12x squared minus 30x minus 18. And the 7 goes away because it's a constant. Now, we just have to set this equal to 0 and find x. So first, we can already see that we can divide everything by 6 on both sides. So we'll just end up having 2x squared minus 5x minus 3 equals 0. Now, when we factor this out, let's do it here. Okay, now we have our roots for f prime of x. We're going to make a sign diagram to see where the intervals of f is increasing or decreasing. So on these lines, we're going to put our roots, which is negative 1 over 2 and 3. And when you plug in any value that's less than negative 1 over 2, this is going to be positive. And when you plug in any value in between negative 1 over 2 and 3, it's going to be negative. And you can figure out just by plugging literally any number. So you can, and make sure to plug this into f prime of x. So if you plug in f prime of negative 1, this will become a positive number. And I'm just skipping the calculation because that's just a simple calculation. And now any number that's greater than 3 will become positive. So now, wherever there's a positive and negative is where the function is increasing or decreasing. So positive is up, negative is down, and positive is up. So now we can write our function is increasing when it's between the interval negative infinity to negative 1 over 2 union 3 to infinity. And now it's decreasing in between negative 1 over 2 to 3. And that's the final answer. And also, these are open parentheses and we're not including these points. And that's because at negative 1 over 2 and 3, f prime of x is actually 0 because that's what we found here. So when it's 0, the function is actually stopped. It's not increasing or decreasing, it's just stationary. And that's why it's open parentheses and not closed, and that's why we don't include these points. Okay, question 2, we have find the intervals on which f of x equals x cubed minus 3 over 2 x squared is increasing or decreasing. So once again, we have to find the values where f prime of x equals 0. So f prime of x equals 3x squared minus 3x. Once again, just by using the power rule. And now we set it equal to 0. So now we can factor out 3x. And this just becomes x minus 1 equals 0. So now we know that x equals 0 and 1. So now let's put this into a sign diagram. Zero and 1. And when you plug in a value into f prime of x less than 0, it's going to be positive. And when you plug in a value in between 0 and 1, so like 1 over 2, it's going to be negative. And when you plug in a value greater than 1, it's going to be positive. So now we know that this is going up, down, and up. So that means our intervals of where f of x is increasing is between negative infinity through 0, union 1 through infinity. And where it's decreasing is between 0 through 1. And this is our final answer. Okay, number 3, we have find the intervals on which f of x equals x to the 4 plus 1 over x squared is increasing or decreasing. So to find the derivative, we need to use the quotient rule. So let's just say u equals x to the 4 plus 1, v equals x squared, du equals, using the power rule, 4x to the 3, and 1 is just 0 because it's a constant, and dv is 2x, and vdu is 4x to the 5 minus udv is 2x times x to the 4 plus 1, all divided by v squared, which is just x to the 4. And this equals 0. And now to find the points of horizontal and vertical tangency, we need to set the top and the bottom equal to 0 separately. So first, we have 4x to the 5 minus, and then 2x to the 5 minus 2x equals 0. So this is just 2x to the 5 minus 2x equals 0. And when you factor out 2x, you're left with x to the 4 minus 1 equals 0. So we know that the points of horizontal tangency are x equals 0 and 1 and negative 1, because x to the 4 equals 1, since it's a cube or quad root, I guess, it's positive 1 and negative 1. And points of vertical tangency is just x to the 4 equals 0, so x is just 0. And since we have two that are the same, the vertical tangency is going to take over, because this implies that at x equals 0, the function doesn't exist because it's a vertical tangent line, right? So the slope, there's no slope there. The slope is undefined. Okay, so now we can draw our sign diagram. And we have 0, 1, and negative 1. So 0 is actually, so negative 1 we can just draw as a solid line. Negative, or 0 now, because we're taking this as a vertical tangent line, where x equals 0, we're going to draw a dotted line to imply that it's not really there. It's just because the slope is undefined at that point. So that's why we draw a dotted line, and we draw a solid line for just 1. And when you plug values in these intervals into f prime of x right here, or right here, this is going to be the outcome. It's going to be negative, positive, negative, and positive. So now we can say the points where f of x is increasing is negative 1 through 0 and 1 through infinity. And the points where f of x is decreasing is negative infinity to 1 and 0 through 1. And this is our final answer.